Okay, let's jump right in. Today we're doing a deep dive on Lightning Data Service, LDS for Lightning Web Components.
Yeah, LDS.
Some folks call this the Apex-free approach to handling data in Salesforce, and it's a pretty fundamental architectural choice.
It really is. And just so we're all on the same page, LDS is essentially this really smart client-side data access layer.
Client-side, okay.
Right. It's built on the UI API, the user interface API, and it functions as like a shared cache. Sits between your components and the database.
Very clever.
A shared cache.
Interesting. So our goal today, our mission, is to sort of give you the inside track, show you why LDS is just core, why it's the design pattern you need for speed, efficiency, and importantly, security in modern apps.
Absolutely. And the benefits hit you straight away. Let's talk efficiency first.
Go for it.
With LDS, you basically eliminate, I'd say, maybe 90% of that boilerplate Apex controller code you'd normally write.
You mean for just simple CRUD, create, read, update, delete?
Exactly. All those basic operations. Less code, faster development, way less maintenance hassle down the line.
I'd say that's huge. Fewer lines of code, sure, but also fewer security reviews for simple stuff, right? It frees you up.
It absolutely frees you up for the actual complex logic, but you raised a good point implicitly. If we're skipping Apex, where security checks often live, how's the data kept safe?
Yeah, that was my next question.
That brings us neatly to the second and maybe the most critical benefit. Automatic security enforcement.
Automatic? How?
LDS does it intrinsically. It respects the logged in user's permissions automatically. We're talking field level security, FLS, object CRUD permissions, sharing settings, all of it. It's baked in. You don't write manual checks for this stuff.
Wow. So if my profile says I can't see like the salary field on a contact, LDS just won't give it to the component, even if I ask.
Precisely. It filters it out based on the user's permissions before it even hits your component code. That just cuts out a massive amount of potential security issues right at the source.
Okay, that's impressive. What else?
Well, there's data consistency.
Yeah.
That shared cache we mentioned, it guarantees it.
How so?
Imagine you update an account name in, say, component A. Any other component on that page, component B, component C, that's also displaying that account record. LDS automatically tells them the data changed and refreshes them. You don't write any code to sync them up. It just happens.
Wow. So no more manual state management headaches for shared records.
Exactly. And that client-side caching, big performance boost. Fewer trips back and forth to the server, much snappier UI.
Okay, benefits are clear. Speed, built-in security, consistency. Sold. How do we actually use it? What are the main ways?
Right, let's get practical. There are basically three main ways to implement LDS. Method one is the simplest, the declarative path.
Declarative, meaning the pre-built component.
Exactly. Things like Lightning record form, perfect if you just need a standard layout to view, edit, or create a record, quick and easy.
And for custom layouts, if you don't want the standard fields.
Then you'd reach for Lightning record edit form or Lightning record view form. Lets you arrange the fields exactly how you want.
And the key thing here is these forms handle stuff like validation too, right?
Yep. Validation, UI API messaging, it's all handled natively. More boilerplate avoided.
Okay, that's method one. Simple. What's next?
Method two involves reactive reading using wire adapters. This is where the @wire decorator comes in.
@wire, right? With adapters like get record.
Exactly. Get record from Lightning re-record UPI is the common one here. The key concept is reactivity.
Meaning if the data, it depends on changes, it reacts.
Precisely. If your component's recorded property changes, maybe the user clicks a different item in a list, the @wire service automatically detects that change and refetches the data. Like the new account's name and industry, for example.
Without you writing explicit refresh logic.
Correct. It just updates based on the reactive variable changing.
Okay, so declarative for simple forms, wire for reactive data reads. What's the third way?
Method three is for imperative writing. Think actions. Create, update, delete. Things that happen usually when a user clicks a button.
So not automatic reactivity, but user-triggered actions.
Exactly. Here you'll call JavaScript functions directly, like update record or create a record, also imported from the UI API modules.
So quick recap.
Yeah.
@wire, when the platform should react to state changes. Imperative calls when the user triggers a specific database action.
You got it. And the really neat part, even after your imperative call, like update record, finishes successfully.
Yeah.
LES still handles the refresh. It notifies all the other components on the page using that record, ensuring everything stays consistent automatically.
That's the magic of the shared cache again.
That's the magic. It really makes LDS more than just a feature. It's like the foundational way to handle data in LWC. Lets you focus on your unique business logic, not the data plumbing or the security basics.
So wrapping this up, for you, the listener, LDS means cleaner code, faster apps, and much more inherent security.
Definitely. It streamlines so much. Which leads to maybe a final thought for you to consider.
Cool.
Think about all the time you save. Not just writing left Apex, but skipping those manual security checks on every single component that touches data.
Yeah, that adds up quickly.
So the question is, with all that time back, what truly complex, innovative business functionality could you build now that the platform is handling that data access foundation for you? Something to chew on.